Night settles over the Giza plateau, the desert cools, the air grows still, and the Great Pyramid looms like a frozen wave of stone, too vast, too precise, too silent to seem like the work of mortal hands. Beneath its shadow, a question older than civilization itself begins to whisper. What if Egypt didn't build this? For centuries, we've been told a story that fits neatly into textbooks, tour guides, and museum plaques. Around 2580 BC, during Egypt's 4th dynasty, Pharaoh Khufu supposedly ordered his architects to construct a tomb that would secure his passage into eternity. The logistics alone sound superhuman. More than 2.3 million blocks, each averaging 2.5 tons, stacked with near-machine precision to a height of 146 metres. Tens of thousands of labourers, we're told, quarried limestone, hauled granite from 800 kilometres away, and assembled this mountain in just 2 decades. It's a remarkable claim, a story of human achievement that inspires wonder. But when you trace its origins, when you examine the evidence with careful eyes, you find that most of it rests not on ancient records, but on modern interpretation. The first written description comes from the Greek historian Herodotus, who visited Egypt around 450 BC, roughly 2,000 years after Khufu's supposed reign. Herodotus never witnessed the construction. He merely repeated stories that Egyptian priests told him, tales of ramps and quarries and 20-year labour projects. But his accounts also mention other things, strange things, winged machines and sacred magic that raised the stones, details that modern historians quietly omit from their textbooks. In fairness, Herodotus wasn't lying. He was a collector of stories, part historian, part mythographer. Yet every classroom lesson about the pyramid begins with his second-hand words, written 2 millennia after the fact. Close your eyes now. Let your breathing slow. Feel yourself drifting back through time, past the scholars and archaeologists, past the pharaohs and priests, to a moment when this monument was already ancient, already mysterious, already waiting in the desert with its secrets locked in stone. Tonight we ask the question that archaeology fears to consider. What if Egypt inherited the Great Pyramid from a civilization that came before? Our journey begins in the 19th century, in the age of imperial archaeology, when European explorers descended upon Egypt like treasure hunters racing for gold. Among them was a retired British colonel named Richard William Howard Vyse. Picture him, middle-aged, his fortune dwindling, his reputation unremarkable, desperate to make a discovery that would etch his name into history. Vyse arrived at Giza in 1835, but he was not an archaeologist. He had no training in careful excavation, no patience for the slow work of uncovering the past. What he brought to the ancient monument was not precision or scholarship. He brought gunpowder. Let that image settle in your mind as you drift deeper. The Great Pyramid, silent for thousands of years, suddenly shattered by explosions. Clouds of dust and smoke billowing through corridors that had known only stillness. The crack and thunder of dynamite breaking ancient granite, stone that had rested undisturbed since before Rome, before Greece, before recorded memory itself. Vyse spent months in 1837 blasting his way through sealed passages, destroying ancient stonework with the casual violence of a man who valued discovery more than preservation. His Egyptian workers watched in horror as he used explosive charges to force his way into chambers that had been closed for millennia. But week after week passed and still he found nothing. No inscriptions naming the builder, no treasures to justify his destructive methods, no proof to secure his place in history. His money was running out, his reputation among fellow explorers was crumbling, time was slipping away like sand through his fingers. Then, in late March of 1837, after weeks of fruitless destruction, Vyse's team broke through into a series of small chambers above the king's chamber. These narrow spaces, now called the relieving chambers, were never meant to be entered. They were structural voids, designed by the original builders to distribute the pyramid's enormous weight. In the highest of these chambers, in the flickering light of oil lamps, Vyse's men reported seeing something that would change Egyptology forever. Red painted marks scattered across the granite beams, hieroglyphic symbols, crude and roughly drawn, and among them a cartouche, the oval frame enclosing a pharaoh's name. The cartouche read, "Khnum Khufu, breathe slowly and let that moment sink into your consciousness." This was the missing piece everyone had been searching for, the builder's signature, direct evidence that Khufu commissioned the Great Pyramid. Overnight, Weiss's name entered the annals of history. The discovery was celebrated across Europe. The textbooks were rewritten, the case, as they said, was closed. But science, when done properly, never truly closes its case. And years later, when other Egyptologists examined these marks more carefully, troubling questions began to emerge. The red marks were painted, not carved. This is significant. In every other royal tomb throughout Egypt, hieroglyphs were carefully, precisely chiselled into stone, permanent declarations of pharaonic power meant to last for eternity. But these marks in the pyramid were hasty, crude, almost like graffiti scrawled by a careless hand. More troubling still, some of the hieroglyphs were misspelled. Not subtle variations or regional dialects, but clear errors that no trained ancient Egyptian scribe would ever make. The symbol used for Khufu's name was wrong, a hieroglyph that didn't even exist during a supposed era. And here's where the story becomes truly suspicious. That exact same misspelling appears in a hieroglyphic reference book published in London in the early 1800s, just years before Weiss's expedition. A book that Weiss owned, a book he cited in his personal notes, a book that sat in his possession as he worked alone in those sealed chambers. Let your mind drift over this coincidence as you sink deeper into relaxation. Picture Weiss, desperate and running out of time, with a pot of red ochre paint and a reference book of hieroglyphs, alone in a chamber no one else could access. Modern analysis of the pigment has revealed more anomalies. The red ochre looks unnaturally bright for paint supposedly 4,000 years old. Ancient paint develops characteristic patterns, micro-cracking from temperature fluctuations, fading from chemical reactions with stone, a certain weathered quality that comes with millennia. These marks showed none of that. Even more damning, careful examination revealed that the red paint sits on top of the quarry marks, the guidelines ancient workers carved into stone to help align the blocks during construction. If these hieroglyphs were painted by the original builders, they should be underneath these work marks, or at least contemporary with them. Instead, they appear to have been added after the pyramid was already built, after the blocks were already set in place. Modern researchers like Zechariah Sitchin and Scott Creighton have studied high-resolution photographs of these marks. They point out irregularities invisible to the casual eye, brush strokes inconsistent with ancient paint application, pigment that lies above dust layers rather than beneath them, strokes that end abruptly as if drawn from awkward angles by someone standing on makeshift scaffolding. Some marks even run beneath later chisel lines from when Weiss's team extracted samples, clear evidence, they argue, that the paint was freshly applied. Chemical analysis in the late 20th century found another troubling detail. The red ochre pigment shows no crystallization or mineral breakdown, processes that typically affect ancient paint after thousands of years. Under magnification, it looks disturbingly modern. Some researchers have even detected traces consistent with industrial iron oxide, the kind found in 19th century paint sources, and perhaps most suspicious of all, in the original field notes from Weiss's expedition, there is no clear mention of these crucial cartouches. The first detailed reference appears only in Weiss's later published journal, written after he had dismissed or fallen out with several of his original foremen, including the very men who first entered the chamber. A pattern begins to emerge, not of discovery, but of desperation. Imagine Weiss that night, his funds exhausted, his reputation in ruins, his time running out. One stroke of fortune could transform him from a failure into a legend. All he needed was a pharaoh's name, a few painted hieroglyphs, copied from a book, applied in the darkness with red pigment and a brush, and the course of history would be changed forever. Was it forgery? We cannot say with absolute legal certainty, but even cautious, mainstream historians admit the inconsistencies are deeply troubling. Some have quietly suggested that Weiss's discovery deserves far more scrutiny than it has received. The irony is profound and unsettling. The entire chronology of ancient Egypt, the attribution of humanity's greatest monument, leans heavily on a few centimeters of red pigment discovered by a man using dynamite in a desperate rush for fame. If those marks are younger than the pyramid itself, if the name Khufu is a Victorian fabrication, then every date that depends on them begins to drift backward into an era we do not remember, into a time before Egypt as we know it even existed. Let that thought wash over you like a wave as you sink deeper into sleep. The story of the Great Pyramid doesn't end with a British explorer's brushstroke. It begins there. Because the moment we admit that its authorship might be uncertain, we must confront an even more profound question. When was it actually built, and by whom? Dating a structure made entirely of stone sounds straightforward until you actually try. Stone, by its nature, contains no organic material, no carbon to measure, no internal clock marking the passage of time. It simply exists, silent and ageless. To science, stone is mute. And so archaeologists have spent decades trying to make the pyramid speak in other ways, through the mortar between its blocks, through artifacts found nearby, through association with other dated structures. But each time they do, the evidence fractures into contradictions that deepen the mystery rather than solve it. The first serious attempt came in 1984, when Egyptologist Mark Lehner and a team of researchers funded by the Edgar Cayce Foundation undertook a radiocarbon study of the pyramid's mortar. The technique, known as carbon-14 dating, measures the decay of radioactive carbon isotopes in once-living material, tiny remnants of straw, charcoal or plant fibre embedded in the ancient lime plaster between the stones. Their results, published in archaeology magazines, seemed at first to confirm the orthodox view. Many dates clustered around 2500 BC, conveniently matching Khufu's supposed reign. Egyptologists celebrated. The Great Pyramid, they declared, had finally been scientifically dated. But let your mind drift over a closer reading of that data, and a different story emerges. The samples varied wildly, some as much as 380 years older or younger than Khufu's era. One fragment dated closer to 3000 BC, centuries before his dynasty supposedly even began. The team attributed these discrepancies to old wood, organic material reused from earlier generations. But this explanation, while tidy, glosses over a deeper problem. It assumes what it tries to prove. If the pyramid's date is already known, then any data that doesn't fit must be explained away as contamination or reused material. Yet the scientific reality is far messier than this comfortable narrative suggests. Mortar, by its nature, represents not original construction, but maintenance and repair. Over millennia, the pyramid has been restored repeatedly, by later pharaohs, by priests, by medieval builders, by modern conservators. What the 1984 study may have measured could be anything. Patchwork repairs from the Middle Kingdom, material inserted during Ptolemaic restoration, even patches from Islamic-era maintenance. Carbon-14 dating doesn't tell us when the stone was laid. It only tells us when the last living fragment mixed into the mortar died. To put it simply, dating the mortar between pyramid blocks is like dating the dust on your bookshelf and calling it the age of your house. Later studies deepened the confusion rather than resolving it. In the 1990s, researchers from the University of Zurich reanalyzed similar samples and again found broad discrepancies, dates spanning nearly 1,000 years. Some pieces even predated the entire Egyptian civilization as we understand it, pushing back into an era we call prehistoric. When independent researchers requested new samples for testing, access was abruptly denied. Official statements cited preservation concerns, but unofficially whispers suggested that no one wanted more anomalies, more questions, more evidence that might challenge the established timeline. Then, in 2020, something remarkable happened. An accident in a Scottish museum changed everything. A curatorial assistant at the University of Aberdeen, Abira Lerdney, was cataloguing old donations when she stumbled upon a small cigar box wrapped in a 1946 newspaper. Inside lay a splinter of cedar wood, dark and dry, carved into a rod-like shape. A faded label read, "From the Great Pyramid, Dixon Relics." Let your breathing slow as you absorb the significance of this discovery. In 1872, British engineer Wayman Dixon had discovered 3 small objects in one of the pyramid's hidden shafts: a granite ball, a bronze hook, and this cedar fragment. The first 2 artifacts ended up in the British Museum, but the wooden piece had vanished for more than a century, lost in the archives, forgotten by history. When Ella Daney found it and sent it for radiocarbon dating, the results stunned everyone. The wood dated to 3,341 to 3,094 BC. That makes it 5 to 8 centuries older than Khufu's lifetime. Older even than Egypt's first recognised pharaohs. Older than the unification of Upper and Lower Egypt under Menes. The explanations came quickly, as they always do when evidence threatens established narratives. Some scholars claimed that cedar trees could live for centuries, suggesting the wood might have been old when used. Others argued possible contamination. But the fact remains, this is the only direct organic artifact ever found inside the pyramid structure, sealed in a shaft since construction, and it places the monument's material at least 500 years before its supposed builder was born. If true, that single splinter of wood doesn't just adjust our timeline, it shatters it. It suggests the Great Pyramid belongs not to Khufu's Egypt, but to a far more ancient world, a civilization that built in stone before Egypt as we know it even existed. Let that possibility drift through your consciousness as you relax deeper. Picture a pyramid already ancient when the first pharaohs gazed upon it, a monument inherited rather than built, claimed rather than created. But the dating mysteries don't end with carbon analysis. The pyramid's surroundings whisper the same story of impossible age. At Saqqara, the step pyramid of Djoser, officially older than Khufu's pyramid, shows erosion patterns strikingly similar to those at Giza, even though its masonry is softer and should weather more quickly. If both structures experienced the same level of wear, logic suggests they endured similar spans of time, far longer than the few hundred years that separate them in the orthodox timeline. But Egypt's current desert climate, dry and stable for thousands of years, cannot account for the deep vertical channels and rounded grooves cut into the limestone. Those marks require centuries of heavy rainfall, the kind that ended around 5000 BC when the Sahara transformed from a green savanna into the desert wasteland we see today. Consider the implications as you sink into the comfortable darkness of sleep. If the pyramid shows water erosion from that era, then its lower courses could predate Egypt's dynasties by thousands of years. The monument would belong not to the Bronze Age civilization of the pharaohs, but to the Stone Age world of the African humid period, when grasslands covered the Sahara and monsoon rains fell where now there is only sand. Even the ground beneath the pyramid tells this story. Sediment cores from the Nile Valley reveal flood layers dating back more than 7,000 years, evidence of a wetter climate when the region received far more rainfall than today. Limestone pavement around the pyramid base shows heavy erosion patterns suggesting exposure to water, long vanished from the region's climate record. The Sphinx enclosure beside the pyramid displays the same telltale signatures, deep, rounded grooves carved by water, not wind. Geologist Dr. Robert Schoch, after detailed stratigraphic study, concluded that this erosion occurred between 9000 and 7000 BC, an age consistent with the late Ice Age's final floods, when glaciers melted and sea levels rose dramatically across the planet. If that conclusion is accurate, then both the Sphinx and the Great Pyramid belong not to Khufu's Egypt, but to an earlier world entirely. One that disappeared when the Sahara dried and civilization, as we understand it, rebooted along the Nile's banks. Still, orthodox archaeology resists this conclusion with remarkable tenacity. Why? Because it destabilizes everything built upon the current timeline. Not just Egypt's chronology, but humanity's entire story of progress. If the Great Pyramid is older than writing itself, then the history of civilization stretches back not 5,000 years, but perhaps 12,000, deep into the Younger Dryas period, when global sea levels rose and ancient coastlines drowned beneath the waves. The question then shifts from who built it, to something far more profound. What were they trying to preserve? When engineers attempted to date the pyramid using luminescence dating, a method that measures trapped electrons in minerals to determine when stone was last exposed to sunlight, they found inconclusive and contradictory results. Some blocks registered ages older than Khufu, others appeared younger. Even the light trapped in the pyramid's crystals refuses to confirm the official story. And so scientists have begun to treat the Great Pyramid as what it may truly be, a palimpsest, a monument built in layers across vast stretches of time. Perhaps an ancient core constructed in an era we've forgotten was later refurbished by successive dynasties. Perhaps each civilization simply claimed it as new, adding their own touches, performing their own restorations, writing their own stories over older truths they could no longer read. In that sense, Khufu may not have built the Great Pyramid at all. He may have merely inherited it, restored it, maintained it, and left his name where earlier hands had long vanished into the mists of time. The carbon fragments, the cedar wood, the uneven data, the water erosion, all hint at a truth that challenges our most fundamental assumptions. Beneath Egypt's known history lies a deeper, older foundation. The Great Pyramid, it seems, does not belong to any one era or any one people. It belongs to time itself, and its silence is not emptiness but patience, waiting for us to ask the right questions. Let your mind drift now to the monument itself, to the physical reality of what stands before us in the desert. Because even if we accept every official claim, even if we ignore the questionable cartouche and the problematic dating, we still face an engineering problem that defies rational explanation. The Great Pyramid is not just large, it is mathematically, logistically, physically absurd. Close your eyes and picture the scale. The structure rises 146 meters into the sky, its base covering over 13 acres, an area large enough to fit St. Peter's Basilica, Westminster Abbey, and the cathedrals of Florence and Milan combined. Each side of the base measures approximately 230 meters, forming a near-perfect square. Yet the difference in length between the longest and shortest sides is less than 2 centimeters. Across 230 meters of stone, that's a deviation of less than 0.01%. The base is leveled to within 2.1 centimeters across its entire footprint. Modern construction projects using laser levels and GPS guidance rarely achieve such precision on projects of this scale. The structure is oriented to true north with an accuracy of 0.05 degrees, roughly 3 arc minutes. Even with our satellites and computers, we struggle to match such alignment when building on this scale. Now consider the timeline. We're told this entire structure, all 2.3 million blocks averaging 2.5 tons each, was assembled in approximately 20 years. Let those numbers sink in as you relax deeper. Do the mathematics in your drowsy mind. 2,300,000 blocks divided by 20 years equals 115,000 blocks per year. Divided by 365 days, that's 315 blocks per day. Assuming a 10-hour workday, that's more than 31 blocks per hour. 1 block every 2 minutes, for 20 years straight. No weekends, no holidays, no breaks. Every 2 minutes, workers would need to quarry a multi-ton block, transport it, sometimes from quarries 800 kilometers away, bring it up the pyramid's growing height, and set it in place with precision that wouldn't accept a deviation of more than a few millimeters. Even with modern cranes, diesel-powered trucks, and computer-aided design, no construction project in history has achieved that pace of work at that scale. Yet we're told the ancient Egyptians accomplished this miracle with copper chisels and wooden sledges. Let your breathing slow as we examine those tools. Copper ranks 3 on the Mohs hardness scale, a measure of mineral resistance to scratching. Limestone, the pyramid's primary building material, ranges from 3 to 4 on that same scale. In theory, copper tools could work limestone, though they would dull quickly and require constant sharpening or replacement. But here's where the story breaks down completely. Many of the pyramid's most crucial elements are made of granite, which ranks between 6 and 7 on the Mohs scale. Copper tools simply cannot cut granite. This isn't a matter of skill or technique or determination, it's basic physics. Copper is too soft. Modern experimental archaeologists have repeatedly attempted to replicate ancient granite cutting methods. In controlled laboratory conditions, copper chisels barely scratch granite surfaces before bending. Researcher Dennis Stock spent years trying to prove ancient methods could work. After hours of intensive effort, his team managed to cut a few millimeters into limestone. Against granite, their tools were essentially useless. To shape just one of the 80-ton granite beams in the king's chamber using copper would require thousands of chisels, constant reforging of tools, and potentially months of continuous labour per block. The pyramid contains hundreds of these granite elements. Some researchers suggest that the Egyptians used dolerite pounding stones to chip away at granite surfaces, but even dolerite is brittle and would fracture under repeated heavy impacts. Photographs of ancient quarries at Aswan show something far more perplexing. Circular pits and straight tool marks that look more like precision drilling than primitive pounding. When engineers studied these grooves under magnification, they discovered spiral striations, the unmistakable signature of a rotating tool cutting through stone in continuous helical patterns. These marks are identical to those produced by modern rotary drill bits spinning at high speeds. Engineer Christopher Dunn, a precision manufacturing expert with decades of experience in aerospace tooling, created computer models of these marks. His analysis revealed that the feed rate, the speed at which the tool advanced through the granite, was equivalent to a drill spinning thousands of times per minute, applying pressure far beyond what human hands could generate. In modern industry, similar marks appear only when materials are shaped by diamond-tipped tools or ultrasonic cutting equipment. If ancient Egyptians achieved the same patterns with copper tubes and abrasive sand, as orthodox theory claims, they would have needed centuries to complete just the internal chambers. Let your mind drift to the question of transportation as you sink deeper into relaxation. Some of those granite beams weigh up to 80 tons and were quarried in Aswan, over 800 kilometers to the south. How were they moved across that distance? The Nile would have offered a natural highway, a river road stretching from south to north. But physics intervenes with its immutable laws. Modern naval engineers who have studied this problem point out a fundamental issue: the buoyancy limits of wooden vessels. In the 1990s, researchers actually built a replica barge using ancient Egyptian techniques and materials. The moment they loaded it with 60 tons of granite, the vessel's timbers cracked and it began taking on water. They never even approached the 80-ton beams that rest in the pyramid's heart. Even if we somehow solve the river transport problem, we still must haul these massive stones from the Nile's edge up to the Giza plateau and then up the sides of a growing pyramid that eventually reached 146 meters in height. Orthodox theory proposes ramps, but the mathematics of ramps create their own impossibilities. To achieve a gentle enough incline for workers to pull multi-ton blocks, a straight ramp reaching the pyramid's peak would need to stretch over a kilometer in length. Such a ramp would contain more material than the pyramid itself. Not a single trace of such a ramp survives. No foundations, no debris fields, no massive quarries where the clay and stone would have been extracted. Some suggest a spiral ramp wrapping around the pyramid's exterior. But this too fails under scrutiny. A ramp curling upward would obscure the builder's sight lines, making it impossible to maintain the precise corner alignments and angles. It would also require the removal of millions of tons of material once construction ended, work for which, again, no evidence exists. In 1978, the Nippon Television Corporation of Japan, working with Egypt's Supreme Council of Antiquities, attempted to test these theories. They set out to build a miniature replica of the Great Pyramid, using only materials and techniques supposedly available to the ancient Egyptians. Their pyramid would stand just 20 meters tall, a fraction of the original. From the start, it was a disaster. Copper chisels failed to shape even small limestone blocks. Ropes snapped under moderate loads. Workers couldn't drag sledges across sand without enormous amounts of water for lubrication. Even with water, the sledges bogged down. Eventually, frustrated and behind schedule, the team resorted to modern steel tools and diesel-powered cranes just to lift the smaller blocks. Even then, their pyramid reached only 10 meters, half their modest target, before the project was abandoned. Their final report, quietly filed away and rarely cited, contained a remarkable admission. No known ancient technique could account for the precision or scale of the Great Pyramid's construction. Let those words echo in your drowsy mind as you drift towards sleep. The conclusion of scientists using modern knowledge and attempting to replicate ancient methods: it cannot be done. To match the precision of Giza today, engineers would need laser alignment systems, GPS calibration, and hydraulic cranes capable of lifting 100 tons. Yet somehow, according to mainstream history, Bronze Age builders accomplished it all with nothing more than rope, wood, and human determination. The paradox is inescapable. The Great Pyramid is both elegantly simple, 4 triangles on a square base, and impossibly complex in its execution. Its construction required understanding of mathematics, logistics, material science, and engineering that defies its alleged age. If it wasn't built by 4th dynasty Egyptians with copper tools and manual labour alone, then how was it built? And by whom? That question hangs in the desert air like heat shimmer, distorting everything we thought we knew. But before we can answer it, we must examine something even more mysterious than the construction itself. We must look at the precision, stand at the base of the Great Pyramid, close enough to touch its weathered surface, and something remarkable becomes apparent. What first appears as rough, ancient stone reveals itself to be something far stranger under closer inspection. Each massive block fits its neighbour with surgical accuracy. The seams between them are thinner than a sheet of paper. Run your hand along the joints, and you'll find surfaces so smooth and true that modern stonemasons struggle to comprehend how they were achieved. For centuries, scholars have tried to explain this precision. Every answer dissolves beneath the weight of evidence, leaving only the paradox itself. The oldest monument on Earth is also its most precise. When 19th century surveyor Flinders Petrie brought his instruments to Giza, he expected imperfections. What he found astonished him so profoundly that he initially doubted his own measurements and rechecked them repeatedly. The pyramid's base covers more than 13 acres, yet the height difference between its corners is less than 2 centimetres. The 4 sides deviate from true north by a mere 3 minutes and 6 seconds of arc, 1/20th of a single degree. Even with GPS and laser levelling equipment, modern engineers rarely achieve this level of accuracy on projects of comparable scale. How then could people working with rope, plumb bobs, and copper chisels produce such alignment? Egyptologists suggest that ancient surveyors observed stars, using the pole star Thuban in the constellation Draco to mark true north. But astronomers who have calculated the positions of stars in 2500 BC point out that Thuban was slightly offset from true north, enough to create a larger deviation than the pyramid actually shows. In fact, the Great Pyramid's orientation is more accurate than observatories built 4,000 years later, constructed by civilizations with far more advanced astronomical knowledge. The deeper you examine the structure, the stranger it becomes. Let your mind drift over the casing stones that once covered the pyramid's surface. Most were removed centuries ago, carried away to build medieval Cairo. But the surviving examples display a level of craftsmanship that borders on the impossible. Some joints measure less than 0.5 millimetre, roughly the thickness of a fingernail. The surfaces are polished to what engineers call optical flatness, a degree of smoothness typically associated with precision mirrors or telescope lenses. Engineers from the French Institute for Research in Engineering and Construction studied these blocks in the 1990s using modern measuring equipment. They found tolerances comparable to precision-machined metal parts. One engineer described it as the accuracy of a modern aircraft wing, applied to millions of tons of rock. The foundation stones beneath the visible layers display similar mastery. Ground-penetrating radar shows interlocking bedrock terraces engineered to distribute weight evenly across the entire plateau. The result, after thousands of years of earthquakes, sandstorms and temperature swings, the pyramid has settled less than 1/2 inch. To achieve that stability, its builders must have understood both load distribution and thermal expansion, concepts formalised only in the last few centuries. Even the internal architecture obeys laws of precision unknown to the pyramid's supposed era. The Grand Gallery, a 47-metre passage rising toward the King's Chamber, is constructed of granite blocks fitted so tightly that air cannot pass between them. The slope of the gallery, 26 degrees, matches exactly the angle of the pyramid's outer face, suggesting intentional harmonic design. The gallery's corbelled ceiling, with each course projecting inward by a precise amount, reduces structural stress with mathematical efficiency. This cantilevering technique wasn't rediscovered in modern engineering until the 19th century, and then there are the tool marks, tiny signatures carved into the stone that tell their own impossible story. Inside the pyramid, on the granite beams of the King's Chamber, lie spiral striations consistent with high-speed mechanical drilling. Christopher Dunn, a master machinist with decades of experience in precision manufacturing, measured these grooves and found a uniform pitch, meaning the cutting head advanced at a fixed rate as it rotated, as though driven by a lathe or rotary drill operating at thousands of revolutions per minute. Laboratory tests attempting to reproduce these patterns using copper tubes filled with abrasive sand have failed completely. The experimental attempts leave rough, irregular scratches, nothing like the clean, concentric rings visible on the ancient stone. Similar precision appears throughout the Giza complex. At nearby temples, granite boxes cut from single pieces of stone show interior angles meeting at perfect right angles, verified by modern laser alignment tools. Their surfaces are flat to within 1/10,000th of an inch, a standard used today in aerospace manufacturing. Yet these artifacts are attributed to a civilization that supposedly lacked iron tools or advanced measuring instruments. To dismiss these anomalies as coincidence is to ignore the sheer consistency of precision across the entire site. Every block in the pyramid, millions of them, fits into a geometry so exact that when the structure was intact, the ratio of height to base perimeter encoded the mathematical constant pi to 3 decimal places. The side angles embody the golden ratio found throughout nature and later in Renaissance art. The precision wasn't random or accidental, it was systemic, as if every dimension followed a unified design code. So how did they do it? The orthodox answer insists on simple tools: copper chisels, wooden mallets, dolerite pounding stones, but in repeated reconstructions, at Aswan, at Saqqara, in the Japanese experiment of 1978, these tools fail spectacularly. Copper bends, dolerite shatters, manual polishing produces nothing close to the measured flatness of Giza's granite surfaces. Other explanations verge on the speculative but remain grounded in physics. Some engineers have proposed that the builders used abrasive slurry saws, copper blades combined with quartz, sand and water to grind through granite. While plausible for small pieces, scaling this technique to 80-ton beams strains credibility. Others suspect vibration cutting, harnessing sonic frequencies to fracture the crystal lattice of granite along specific planes. Experimental ultrasonic machines today can slice through hard stone with surprising ease, but such technology belongs to the 20th century, not the 26th BC. Then there's the possibility that the builders didn't cut each stone individually at all, but cast them using a lost form of limestone geopolymer, a kind of ancient concrete. French material scientist Joseph Davidovits proposed this in the 1980s, arguing that some outer blocks show microbubbles and binding textures consistent with reconstituted stone. If true, it would imply advanced knowledge of chemistry and materials engineering. But when samples from deeper core blocks were tested, results pointed back to quarried stone, not cast material. The mystery endured. Perhaps the real secret lies not in tools or materials, but in intent. The pyramid's geometry is not random. It is tuned, calibrated, harmonized in ways we're only beginning to understand. Acoustic tests reveal that the king's chamber resonates at specific frequencies, 440 and 432 Hz, the same frequencies used to tune musical instruments, matching Earth's own electromagnetic resonance, the so-called Schumann frequency. When sound is introduced into this chamber, the entire space vibrates like the body of a colossal instrument. Was this precision a byproduct of artistry, or part of a design that harnessed vibration, sound, or energy in ways we barely comprehend? Even the choice of materials seems deliberate. The outer casing of high quartz limestone would have reflected sunlight brilliantly, while the inner granite core, rich in quartz and feldspar, conducts and amplifies vibration in ways that modern engineers recognize but cannot fully explain. Modern engineers have noted that this combination creates piezoelectric effects, tiny electrical charges generated by mechanical stress or vibration. If that property was known and deliberately exploited, the pyramid might not have been a tomb at all, but a kind of resonant device, using precision itself as a form of power or communication. Whatever the explanation, the paradox remains as clear as the desert air. How did the first great monument of civilization display what appears to be the pinnacle of precision? Every subsequent pyramid in Egypt is demonstrably inferior, less aligned, less stable, less sophisticated in its engineering. History should move the other way. Technologies evolve through trial and error, improving with each generation. But at Giza, perfection appears first and declines afterward, as if the knowledge required to build it was already ancient, already fading, already slipping away into forgotten memory. That inversion suggests something profound, inheritance rather than invention. A monument built by a culture whose mastery was already old, whose knowledge of measurement and geometry came from a deeper lineage now lost to time. Let that thought settle over you like the desert night as your breathing slows and deepens. The Great Pyramid stands as a challenge, not just to our understanding of the past, but to our assumptions about human capability itself. Step inside the Great Pyramid now in your mind's eye as your body relaxes completely. The sunlight dies the moment you cross the threshold. The air turns cool and still, thick with the weight of ages. The walls swallow sound, and darkness folds around you like a second skin. You can feel the weight of millions of tons above your head, pressing down through the centuries. Yet the silence is absolute, profound, almost alive in its intensity. As you trace your hand along the walls, perfectly straight, perfectly smooth, a question emerges from that darkness, whispered by every visitor who has ventured into these passages. How did they see in here? Because to carve this geometry in total darkness seems impossible. If torches or oil lamps had been used during construction, the ceilings should be blackened with soot. Thousands of hours of work by lamplight would leave unmistakable traces: carbon residue, smoke stains, the accumulated darkness of burning fuel. Yet from the descending passage to the king's chamber, not a single smear of carbon exists. The limestone and granite surfaces are pristine, their pale colour untouched by smoke. Even microscopic analysis of the interior, performed by the University of Cairo's Department of Archaeology, confirms that the stone pores contain no trace of combustion byproducts, no unburned hydrocarbons, no lamp soot, no residue of burning oils. This absence is so complete that it borders on eerie. Other tombs and temples from the Old and Middle Kingdom show exactly what you would expect: blackened ceilings, soot crusted into corners, scorch marks from years of flickering flame. The tomb of Seti I in the Valley of the Kings, for instance, displays clear evidence of lamp use throughout its passages. Yet the Great Pyramid, supposedly built 1,000 years earlier, when lighting technology should have been more primitive, is immaculate. So if not flame, what brought light to these depths? The traditional explanation is the mirror theory, that sunlight was reflected deep into the pyramid through a series of polished bronze mirrors, each one bouncing light further into the darkness. Egyptologists still repeat this idea in textbooks and documentaries, but physics, as always, tells a different story. Even the finest polished bronze reflects less than 40% of incident light. After just 3 or 4 reflections, the beam would lose nearly all its intensity, fading into nothing long before reaching the interior chambers, which lie hundreds of feet from any natural light source. To test this theory, physicist Dr. John Baines of Oxford recreated a scaled mirror system in 2016. His experiment showed that by the 4th reflection, less than 3% of the original sunlight survived. The faint glow was insufficient to illuminate a worker's face, let alone provide the bright, steady light required for the precise chiselling work visible throughout the pyramid. Moreover, no archaeological trace of such mirror systems has ever been found. No mounting brackets, no polished bronze discs, no fragments or remnants. The mirror theory, like torchlight before it, burns out quickly under scrutiny. Other hypotheses suggest the Egyptians used oil lamps with filtered wicks or fat-based fuels designed to burn more cleanly. Yet chemistry exposes another flaw. Even low-smoke oils produce measurable soot over time. The longer a lamp burns, the more carbon accumulates on nearby surfaces. The Great Pyramid's untouched ceilings tell us that no open flame ever illuminated its passages for any sustained period. But what if the builders didn't rely on fire at all? Let your mind drift now to the Temple of Hathor at Dendera, over 400 kilometers south of Giza. Deep within this temple lies a relief that has puzzled archaeologists for decades. It depicts priests holding what appear to be elongated bulbs, each containing a serpent-like form and connected by a cable to a box-like object. Some researchers interpret these as stylized symbols of creation mythology, but others, including electrical engineer Eric von Däniken, have suggested the relief represents an ancient lighting device, what he called the Dendera light. When engineers built a physical model of the depicted object using materials available in antiquity, quartz tubes, copper fittings and acid-based electrolytes, it produced a faint glow similar to a low-voltage discharge tube, comparable to early electric lights. To mainstream archaeology, this remains wild speculation. Yet intriguing chemical residues inside the Dendera temple's crypt chambers show traces of zinc and sulfur compounds, the byproducts of galvanic reactions, the same chemistry that produces electrical current in primitive batteries. Coincidence? Perhaps. But it hints at an ancient awareness of electrochemical principles far beyond what textbooks attribute to Egyptian science. Now consider the Great Pyramid's materials through this lens. Its core and inner chambers are constructed of Aswan granite, which contains high levels of quartz and feldspar, minerals with piezoelectric properties. When subjected to pressure or vibration, these crystals generate small electrical charges. Surrounding that conductive granite core are the outer casing stones of white limestone, a strong electrical insulator. In modern engineering, this combination, A conductive core wrapped in an insulating shell forms what's called a resonant cavity, capable of concentrating and amplifying electromagnetic energy. Could the pyramid itself have functioned as a massive energy transducer, converting vibration into electricity or light? In 2018, physicists at ITMO University in St. Petersburg, working with the laser Zentrum Hanover, modelled how electromagnetic waves interact with the pyramid's shape and materials. Using sophisticated computer simulations, they analysed the pyramid's response to various frequencies of electromagnetic radiation. Their results, published in the Journal of Applied Physics, revealed something remarkable. At certain resonant frequencies, the pyramid's internal chambers and the area beneath its base concentrate electromagnetic energy. The geometry of the structure allows it to focus and amplify naturally occurring electromagnetic waves in very specific ways. This doesn't prove the pyramid glowed like a light bulb, but it raises an intriguing possibility. Perhaps illumination wasn't provided by fire or reflected sunlight, but by resonance, by the pyramid itself interacting with Earth's electromagnetic field in ways that produce subtle luminous effects or enhanced human perception. The evidence isn't limited to theoretical mathematics. When modern acoustic researchers tested the King's Chamber with sensitive equipment, they found something extraordinary. It hums. At frequencies between 110 and 120 Hz, the granite walls begin to vibrate audibly, creating a low tone that you can feel in your chest as much as hear with your ears. When that sound harmonizes with lower frequencies, especially around 8 Hz, matching Earth's natural electromagnetic resonance known as the Schumann frequency, the entire chamber becomes a resonant cavity, vibrating in sympathy with the planet itself. In the darkness of that chamber, something remarkable happens. Under infrared cameras, the granite subtly glows, not from any external light source, but heated by the vibration itself, by the friction of molecules oscillating in response to sound. To the ancient builders, this may not have been technology as we understand it, but something deeper. Sacred physics, the harnessing of sound, energy and geometry to create effects that transcend simple illumination. Perhaps light, in their understanding, wasn't merely visual but experiential, an illumination of consciousness itself. Ancient Egyptian texts describe the gods as those who shone with the light and refer to the priestly caste as keepers of the luminous flame that burns without smoke. Modern scholars interpret these as purely poetic phrases, metaphors for spiritual enlightenment. But what if they preserve memory of something literal? What if the pyramid's chambers, properly activated through sound and resonance, produced forms of illumination we've categorized as impossible simply because they don't match our modern understanding of light? Archaeologists have found other hints throughout Egypt that its earliest temples were built for resonance rather than simple ritual. In the underground Serapeum of Saqqara, massive granite sarcophagi, each weighing up to 70 tons, resonate like tuning forks when struck, producing pure, sustained tones. In the Osirian, at Abydos, chambers carved directly into bedrock produce identical low-frequency vibrations when sound is introduced. Acousticians call these standing waves, patterns of vibration that remain stationary in space, creating nodes of intense acoustic energy. Ancient builders may have used these intentionally, creating spaces where sound and light merged in ways our modern compartmentalized understanding of physics struggles to explain. Some historians dismiss these findings as pseudoscience, yet they overlook one crucial fact. The precision required to create such resonant spaces matches the precision of the pyramid's construction itself. Every angle, every chamber dimension, every shaft seems tuned, calibrated, as if the entire structure were an instrument rather than a tomb. When visitors today play low tones inside the King's Chamber, they often describe peculiar sensations, a tingling in their skin, a light-headed feeling, even flashes of brightness at the edge of vision. Some call it imagination, others call it electromagnetic induction, the direct stimulation of the nervous system by the chamber's resonant field. Either way, the experience suggests that the Great Pyramid interacts with the human body on frequencies we rarely consciously perceive, creating effects that ancient peoples may have understood far better than we do with all our modern instruments. So perhaps the light of the pyramid was never purely visual. Perhaps it was something deeper, an illumination of perception itself, an awakening of awareness triggered by resonance, a way to make those who entered see without conventional seeing. Whatever its function, one truth becomes increasingly clear. The Great Pyramid was not built merely to house a corpse. Every measurement, every material choice, every chamber serves a physical and mathematical purpose that we're only beginning to understand. And if that purpose involved light, energy, or resonance, then we are not dealing with primitive builders fumbling in the dark. We are dealing with a civilization that understood principles of physics we thought were discovered only in our modern age, or perhaps understood them in ways we have yet to rediscover. Let that thought settle over you as you drift deeper into sleep. The pyramid's darkness holds its own illumination, waiting not to be seen, but to be understood. Under the desert moon, the Great Pyramid seems less a monument than a message, a vast equation carved into the earth. Its angles rise with purpose, its sides align with the stars, its proportions whisper of balance and order that transcend any single culture or era. For those who study it closely, who measure its dimensions and calculate its ratios, the stones begin to speak a different language entirely. Not hieroglyphs, but mathematics. Not the arithmetic of merchants and scribes, but something older and universal, the geometry of the cosmos itself. This perhaps is where the true mystery of the pyramid lies, not in how it was built, but in what it knows. Let your mind drift over a simple but astonishing fact. When modern engineers measured the pyramid's base perimeter and height with precise instruments, they discovered a ratio that seemed impossible for its attributed era. Take the perimeter of the base, approximately 921.6 meters. Divide it by twice the original height, roughly 293.2 meters. The result is 3.1416, the value of pi drum p, accurate to 4 decimal places. Pi is the ratio of a circle's circumference to its diameter, a fundamental mathematical constant that appears throughout nature and physics. It governs the motion of planets, the spirals of galaxies, the ripples in water, the very fabric of space-time itself. The earliest known written approximation of pi, found in the Rind mathematical papyrus from ancient Egypt, dates to around 1650 BC, nearly 1,000 years after the pyramid's supposed construction, and that approximation was only accurate to about 3.16, far cruder than what the pyramid encodes. Yet here, in stone stacked in 2500 BC, or earlier, we find pi expressed to 3.1416. This isn't a rough approximation, the kind you might stumble upon through trial and error. This is deliberate, precise, a mathematical constant embedded in the very shape of the monument. But pi is not the only secret hidden in the pyramid's proportions. The structure also embodies another crucial constant, the golden ratio, phi, approximately 1.618. This ratio appears throughout nature, in spiral galaxies, in nautilus shells, in flower petals, in the proportions of the human body itself. Renaissance artists rediscovered it and used it to create aesthetically pleasing compositions. Modern designers employ it in everything from architecture to corporate logos. When you divide the slant height of the Great Pyramid by half its base length, you get 1.618, phi to 3 decimal places. The golden ratio supposedly wasn't mathematically defined until Greek mathematician Phidias studied it around 500 BC, 2,000 years after the pyramid's traditional date. These aren't vague correspondences or approximate matches, they're precise to multiple decimal places. The probability of accidentally encoding both pi and phi in a single structure approaches astronomical improbability, but the mathematical mysteries deepen further still. The pyramid's dimensions appear to encode information about Earth itself, knowledge that shouldn't have existed in the Bronze Age. Multiply the pyramid's original height, 146.6 meters, by 43,200. The result is 6,356,400 meters, a 99.7% match to Earth's polar radius. Multiply the base perimeter, 921.6 meters, by that same factor of 43,200. The result is 39,831,552 meters, a 99.8% match to Earth's equatorial circumference. Let those numbers wash over you as you relax deeper. The pyramid knows the size and shape of our planet, encoded at a scale factor of 1 to 43,200. Why that particular number? Because it relates directly to the precession of the equinoxes, the 25,920-year cycle, in which Earth's axis slowly wobbles like a spinning top, changing the apparent position of stars in the night sky. Divide that precessional cycle by 600, and you get 43,200. This presents a cascade of impossibilities. The pyramid appears to encode knowledge of Earth's size and precise dimensions, the fact that Earth is a sphere, not a flat plane, the difference between polar and equatorial measurements, the precessional cycle of Earth's axis, the mathematical relationship between circular and linear measurements, the scaling factor that connects human measurements to planetary dimensions. None of this knowledge appears explicitly in any ancient Egyptian text. Their astronomy was practical, tracking the Nile's floods, organising a calendar based on Sirius rising, not theoretical physics and advanced geodesy. The pyramid's latitude provides yet another mystery. It sits at 29.9792458 degrees north, a number that almost exactly matches the speed of light in meters per second, 299,792,458. The precision is uncanny, matching to the 6th decimal place. Skeptics rightly point out that the metric system didn't exist in antiquity, making this coincidence potentially meaningless. Yet the alignment remains curious, because latitude is a function of Earth itself, not human measurement conventions. Whether the match is coincidence or hints at ancient knowledge of fundamental physics, it adds another layer to the pyramid's cosmic precision. Inside the structure, the same mathematical language continues. The dimensions of the king's chamber create what geometers call a double square rectangle, 10 cubits wide, 20 long, 11 high. This specific ratio generates frequencies associated with musical harmony. When sound is produced inside this chamber, the granite resonates at 440 and 432 Hz, tones that correspond to modern concert pitch and what some call Earth's natural resonance, the Schumann frequency of approximately 7.83 Hz and its harmonics. This is not coincidence. Ancient Egypt's temples, including those at Abydos and Dendera, exhibit similar resonant geometries. Stone-carved halls amplify specific frequencies, sometimes causing entire structures to vibrate like tuned instruments. The pyramid's designers understood that form and frequency are connected, that geometry can shape sound, and sound can shape consciousness and matter itself. In 1998, acoustic engineer Tom Danley recorded standing waves inside the king's chamber that behave exactly like those in a precisely tuned musical instrument. The chamber's resonance amplifies low tones, generating patterns of vibration that pulse through the stone. Modern imaging reveals interference nodes where frequency builds, creating invisible fields of acoustic pressure. To ancient builders, this might have been perceived as the voice of the gods, the living breath of the structure itself, audible proof that the monument was alive with power. The same harmonic principle exists on a planetary scale. The pyramid's geometry, its angles and proportions create ratios that appear throughout nature and cosmos. Its 51-degree slope angle approximates the angle of Earth's orbital tilt relative to the plane of the ecliptic, our planet's relationship to the Sun. Its alignment with Orion's belt and the star Sirius reflects the same sky visible around 10,500 BC, long before Egypt's dynasties began, during the epoch when the Sahara was still green and wet. The builders weren't simply observing stars, they were documenting time on a scale of millennia, freezing the heavens in stone. Even the mathematical constants pi and phi carry deeper symbolism. In sacred geometry, pi represents infinity, the circle with no beginning or end, the eternal cycle. Phi represents life itself, the generative proportion through which matter self-organizes, from spiral galaxies to DNA helixes. Together they embody creation, the eternal and the living, infinity and form. The pyramid in this light can be read as a universal equation describing how life unfolds from eternity, how consciousness emerges from cosmos. This understanding appears in myths worldwide. The Mayan pyramid of Kukulkan at Chichen Itza encodes the solar year in its 365 steps. The temples of Angkor Wat in Cambodia align with precessional cycles spanning 25,920 years, the same great year known to ancient Egyptians. Across continents separated by vast oceans, the same constants, the same celestial ratios, the same mathematical principles repeat as if all these builders were reading from a single source text. the mathematics of creation itself. Modern scientists often dismiss these correspondences as coincidence, as the human tendency to find patterns in randomness. But coincidence begins to sound like language when it repeats with precision across cultures, across millennia, across monuments separated by thousands of miles. If the Great Pyramid truly encodes the constants of Earth, the rhythms of the heavens and the laws of vibration, then it is not merely architecture. It is data, preserved through geometry, a message written not in ink or carved letters, but in proportion and alignment. And if so, it may be the oldest scientific document in human history, a stone record from a civilization that understood the universe as number, sound, and light, long before our modern equations rediscovered the same truths. Let that possibility drift through your relaxing mind. The pyramid stands as a library without words, a textbook without pages, speaking in a language that transcends culture and time. Its mathematics are its message, waiting patiently for minds capable of reading them. When night falls over the Giza plateau, when the last tourists depart and silence reclaims the desert, something remarkable becomes visible. The air cools, clarity deepens, and stars spill across the black canvas of sky. Countless points of light, ancient and eternal. From this vantage point, standing before the Great Pyramid, the horizon seems to bend. The monument's apex points upward like a compass needle aimed at the heavens, and suddenly you begin to understand something profound. This entire complex wasn't built merely for Earth, it was built for the stars. For thousands of years, the ancient Egyptians called their land Kemet, the Black Land, referring to the fertile soil deposited by the Nile's annual floods. But they also called it Tagesret, the sacred land, the mirror of heaven. To them, the sky wasn't empty void, but a celestial river, a divine Nile flowing above the earthly one. The Great Pyramid in this cosmology was the meeting point, the axis where heaven and earth touched, where the eternal and the temporal merged. In 1993, engineer and researcher Robert Bauval made an observation that transformed how we understand Giza forever. Studying aerial photographs of the three pyramids at Giza, he noticed something peculiar that most people had overlooked. The three pyramids aren't arranged in a perfect line, as casual observers might assume. The smallest pyramid, that of Menkaure, is offset slightly to the east, creating an asymmetry in the otherwise orderly arrangement. But Bauval realized this imperfection was anything but random. The same offset, the same asymmetrical pattern appears in the sky. The three stars of Orion's belt, Alnitak, Alnilam and Mintaka. When he overlaid a map of Orion onto the pyramid layout, the alignment was nearly perfect. The relative positions matched. The sizes corresponded, the largest star to the largest pyramid, the smallest to the smallest. Even the offset direction was identical, mirroring the celestial pattern with stunning precision. The Giza plateau, it seemed, was not random architecture but a celestial map, Orion's belt transposed onto the sands of Egypt. But Bauval's discovery didn't stop with spatial alignment. Using astronomical software, he calculated the position of Orion's belt across millennia, adjusting for axial precession, the slow wobble of Earth's rotation that shifts the apparent position of stars over vast periods of time. When he determined the exact moment when the stars of Orion aligned most perfectly with the pyramid's layout, accounting for their position on the horizon and their orientation relative to the Nile, the celestial clock pointed to a specific era, 10,500 BC. Let that date sink into your drowsy consciousness. Not 2,500 BC, the traditional date for the pyramid's construction, but 10,500 BC, over 8,000 years earlier. That date doesn't just fall outside Khufu's reign, it precedes ancient Egypt entirely. It lands near the end of the Younger Dryas period, an era of global cataclysm marked by massive flooding, abrupt climate shifts, and the extinction of Ice Age megafauna. It's also the same epoch when other mysterious monuments appear. Göbekli Tepe in Turkey, the Sphinx's water-eroded body, ancient flood layers in Mesopotamia. Multiple lines of evidence converge on this same moment in deep time. Could the builders of Giza have been commemorating an earlier sky, a celestial memory of a world destroyed? Were they encoding a timestamp in stone, marking the era when their civilization flourished before catastrophe struck? Mainstream scholars resist this conclusion, arguing that the alignment is coincidental, or that Bouval's astronomical interpretations are selective. Yet the correspondences multiply under scrutiny. The pyramid's relative brightness matches Orion's belt. Khufu's pyramid corresponds to the brightest star, Alnitak, Khafra's to Alnilam, Menkaur's to Mintaka, the faintest. Their layout mirrors not only Orion's position, but its declination angle relative to the Milky Way. When viewed from above, the Nile runs across Giza exactly as the Milky Way crosses Orion in the ancient sky, a celestial river reflected on Earth. The Egyptians themselves called the Milky Way the winding waterway of the gods. The dead were believed to sail along it after death, guided by the constellation Sar, the divine name for Orion, toward eternal life in the field of reeds, their paradise. In this cosmic mythology, Orion represented Osiris, god of death and rebirth, while the bright star Sirius nearby symbolized his consort Isis. Each year, Sirius's heliacal rising, its first appearance before dawn after a period of invisibility, heralded the flooding of the Nile, the annual rebirth of Egypt itself. Now consider the pyramid's internal shafts through this celestial lens. The southern shaft from the king's chamber points directly toward Orion's belt as it appeared in the pyramid era. The northern shaft targets the pole star Thuban in Draco. Meanwhile, the queen's chamber's southern shaft targets Sirius, while its northern shaft points to Koshab in Ursa Minor. These aren't random tunnels or simple ventilation ducts, they're cosmic sight lines, celestial alignments connecting the earthly realm of pharaohs to the heavens of gods. To the ancient Egyptians, this wasn't symbolism or art, it was technology, resurrection technology. The pharaoh's spirit, upon death, was believed to ascend through these shafts, travelling along beams of starlight toward Orion, the realm of Osiris, where he would be reborn among the eternal stars. The pyramid itself, in this understanding, was a machine for immortality, a launch pad for the soul. But the precision of these alignments suggests something far more sophisticated than religious symbolism. To achieve such accuracy, the builders had to measure stellar declinations with precision of less than 1 arc-minute, requiring instruments that wouldn't reappear until the Renaissance thousands of years later. They also had to account for precessional drift, a phenomenon invisible to a single human lifetime, taking 26,000 years to complete one full cycle. How could a civilization supposedly born in 3000 BC encode a sky from 10,500 BC, a pattern visible only at the end of the Ice Age? Either they possessed knowledge inherited from an older world, a civilization that had observed the skies for millennia before Egypt began, or the pyramids themselves were built in that earlier age, preserving a snapshot of the heavens that once shone above a different Earth. Evidence for that inheritance lingers in myth and memory. In Egyptian cosmology, Zep Tepi, the first time, marked the era when gods descended from the stars to establish order after a cosmic flood. Osiris ruled Earth, teaching humankind civilization, agriculture, astronomy, until disaster struck and he was slain by his brother Set. Isis resurrected him briefly, conceiving their son Horus, who later avenged his father and restored divine order. To Egypt's priests, the annual rising of Orion symbolized that same resurrection, a story of destruction and renewal written in the stars themselves. Could this myth encode memory of a real event, a cataclysm that destroyed a primordial civilization whose survivors rebuilt along the Nile, carrying with them knowledge of the stars and the skills to encode that knowledge in imperishable stone? If so, the Giza complex might not just imitate the heavens, it might commemorate them, a cosmic memorial to the world before the flood, a civilization that looked up at Orion and saw not merely stars but ancestors, guides, gods who walked Earth during that first time. Astronomical modelling strengthens this connection. When Orion's alignment with Giza peaked around 10,500 BC, the constellation Leo rose due east, directly where the Sphinx faces. The lion-bodied statue weathered by ancient rains may symbolize the age of Leo, the astrological epoch when Orion's alignment was perfect. Together, the Sphinx and the pyramids mark a celestial timestamp, a double signature encoding both space and time in stone. Across the world, similar patterns emerge, suggesting either parallel evolution or echoes of a single global knowledge system. The temples of Teotihuacan in Mexico align with Orion's belt. The complex's main avenue mirrors the Milky Way. The megaliths of Nabta Playa in southern Egypt, dated to around 6000 BC, align with both Orion and Sirius thousands of years before Khufu. Ancient builders everywhere, it seems, looked up and built down, mapping heaven onto earth. Were these parallel discoveries, independent revelations, or echoes of a single prehistoric science of the sky that predated all recorded history? Even modern astronomy cannot fully dismiss the precision of Giza's stellar design. When NASA physicists mapped the pyramid's coordinates against Earth's axial tilt and the orbital plane of Orion, they found geometric relationships that repeat at scales both planetary and galactic, as if the builders had encoded not only where they were but when they were, marking their place in the cosmic dance of Earth, Sun, and stars. Whatever the explanation, one truth remains inescapable. The Great Pyramid isn't a tomb frozen in stone, it's a clock, measuring epochs rather than years. Its geometry and alignments trace the turning of the heavens across millennia, preserving patterns that take 26,000 years to complete. And if it does point back to 10,500 BC, it may hold the memory of a lost chapter in human history. A civilization wiped from Earth's surface but not from the stars, a people who looked up and saw themselves reflected in Orion's eternal belt. Let that cosmic perspective settle over you now as your breathing deepens and sleep draws near. The pyramid stands not as monument to human pride but as mirror of the heavens, a stone echo of stellar patterns that have wheeled overhead since before memory began. You step now into the king's chamber in your mind's eye as your body relaxes completely into sleep. The world outside dissolves, the air is heavy, metallic, still. The granite blocks press inward with a weight you can feel in your bones. There are no paintings here, no carvings, no inscriptions, nothing that identifies this room as the resting place of a pharaoh, the culmination of Egypt's most ambitious monument. Only a rectangular granite box sits near the western wall, lidless, hollow, empty, like an echo waiting for a voice that never came. This is supposed to be Khufu's tomb, the sacred chamber that justified the entire massive construction project, the final destination for a god-king's journey to the afterlife. Yet where other royal chambers overflow with hieroglyphs, gold leaf, ritual texts and treasures, this one is naked. Its silence feels intentional, almost defiant. Let your mind drift over this absence as you sink deeper. In ancient Egypt, death was not an end but a journey, meticulously planned, lavishly documented. Tombs were not mere graves but gateways to eternity, adorned with hieroglyphs that mapped the path through the underworld. The Book of the Dead, the pyramid texts, countless inscriptions guided the soul through challenges and trials, naming gods, reciting spells, ensuring immortality through words of power. Pharaohs filled their resting places with everything they might need. Shabti figurines to serve as magical servants, canopic jars holding preserved organs, offerings of food and wine, treasures of gold and lapis lazuli. Even minor nobles had tombs painted with vibrant scenes of daily life, farming, music, feasting, meant to continue forever in the afterlife. The Valley of the Kings is a library of such stories, each tomb wall shouting its owner's name and deeds to eternity. But the Great Pyramid is silent. No hieroglyphs grace its chambers, no paintings depict the gods, no spells point the way to paradise, just stone, angles, emptiness, and a void where a king's legacy should be. The king's chamber, deep within the pyramid's heart, is a marvel of construction. Its walls are made of massive granite blocks hauled from Aswan, 800 kilometers away, fitted so tightly that a razor blade cannot slip between them. The ceiling consists of 9 massive beams, each weighing 40 to 50 tons, distributing the weight of millions of tons above with engineering that has kept the space stable for over 4,500 years. Inside sits the granite box, often called a sarcophagus. But it's unlike any other burial vessel in Egypt. It has no lid, no carvings, no traces of mummification oils or resins. It's too small to hold the nested coffins typical of royal burials, yet too plain for a pharaoh's grandeur. No body was ever found here. No grave goods, no fragments of ritual objects, no evidence whatsoever that anyone was ever buried within these walls. Compare this emptiness to the tomb of Tutankhamun, discovered untouched in 1922. Howard Carter found walls covered in intricate paintings, rooms packed with over 5,000 artifacts, chariots, thrones, jewellery, weapons, food offerings, sacred texts. The air was still thick with the scent of ancient oils after 3,000 years. That is what a pharaoh's tomb looks like. The Great Pyramid, by contrast, feels less like a burial chamber and more like something else entirely, a laboratory of geometry, a resonant instrument, a space designed for a purpose we cannot name. Some argue the tomb was looted in antiquity, its treasures stolen, its inscriptions defaced or erased. But this theory crumbles under scrutiny. The passages show no signs of forced entry, no chisel marks where thieves broke through seals, no scattered debris from hurried plunder. Tomb robbers in ancient Egypt were not subtle. They left behind shattered pottery, broken furniture, soot from torches. The Great Pyramid shows none of this, no residue, no fragments, not even dust to suggest a burial was disturbed. The granite box itself shows no wear from a lid being pried off or a body being removed. To believe it was looted, you must imagine thieves so meticulous they erased every trace of their presence, leaving the chamber as pristine as the day it was sealed. That's not robbery, that's erasure, and it feels far too deliberate. Others suggest the pyramid was an early prototype, built before the tradition of decorating tombs evolved. But this explanation falters against the evidence of the pyramid's sophistication. The Great Pyramid is no primitive experiment. Its geometry is flawless, its alignment to true north unmatched by any later structure, its internal design a masterpiece of engineering. The Grand Gallery, with its corbelled ceiling, is a structural marvel that later pyramids couldn't replicate. The air shafts extending from the King's Chamber align with stars, Orion's belt and the pole star with precision, suggesting purpose tied to the cosmos, not fumbling trial and error. Later pyramids are demonstrably inferior. Those of Khafra and Menkaure are smaller, less precise, sometimes structurally compromised. The bent pyramid of Sneferu, built supposedly just before Khufu's, nearly collapsed during construction and had to have its angle adjusted mid-build. If anything, the Great Pyramid represents a peak, not a beginning, the culmination of knowledge that was never equalled again, as though the expertise required to build it was already fading, even as the last block was set. So if it's not a tomb, what is it? The absence of burial evidence invites us to reconsider everything. The King's Chamber, with its strange acoustic properties, offers profound clues. Sounds inside, whispers, chants, resonate in ways that feel engineered, as if the space was designed to amplify specific frequencies. Researchers have measured the chamber's dimensions and found they correspond to harmonic ratios, creating resonance that amplifies certain tones while dampening others. A note at around 110 Hz produces a standing wave, a vibration you can feel physically, as though the chamber itself was built to capture and enhance sound. The granite, dense and rich in crystalline quartz, is a natural conductor of vibration. Its structure resonates like a tuning fork when exposed to certain frequencies. Could the pyramid have been a resonance chamber, built to harness sound or energy for purposes we don't understand? The structure's astronomical alignments deepen this mystery. Those air shafts, too narrow for human passage, point to specific stars with precision that requires advanced astronomical knowledge. The pyramid's orientation to true north, its encoding of pi and phi, its dimensions mirroring Earth's size, all suggest understanding far beyond practical tomb construction. Some researchers speculate it was an observatory, a monument designed to map the heavens. But why build it on such a massive scale, with such enduring materials, if it was only for stargazing? A bolder idea emerges, whispered in the fringes of archaeology. What if the Great Pyramid was a machine? Not of metal or wires, but of stone and intention. Not of gears, but of geometry and resonance. Some theorists, inspired by figures like Nikola Tesla, who understood resonance as a fundamental force, suggest it was designed to generate or channel energy, electromagnetic, acoustic, perhaps even forms we haven't discovered. The granite in the King's Chamber, rich in piezoelectric quartz, could act as a conductor, amplifying natural energies. The pyramid's shape, with its precise angles, might focus these forces in ways we cannot yet measure. Experiments with small-scale pyramid models have shown curious effects. Organic materials placed inside decay more slowly, metal blades maintain their sharpness longer. While these claims remain controversial and unverified by mainstream science, they fuel speculation that the Great Pyramid embodied a technology whose purpose was lost when its builders vanished. Then there's the shadow of an even stranger possibility: the pyramid's scale, precision, and silence. the lack of any cultural markers or hieroglyphic stories, have led some to wonder if it was built with knowledge from beyond Earth. Erich von Däniken, in his controversial work Chariots of the Gods, proposed that extraterrestrial beings might have guided ancient architects, sharing mathematics and engineering beyond human capability at that time. The Great Pyramid's anomalies, its alignment, weight distribution, mathematical encoding, fit this narrative. Why else would a civilization build something so vast yet leave no name, no story, no claim? Could it be a beacon, a signal to the cosmos, or a gift from visitors who knew their time on Earth was limited? This idea stretches credibility, but the pyramid's very existence stretches what we believe possible. Its engineering defies the tools we attribute to its era. Its knowledge surpasses what appears in any contemporary text. More grounded, yet no less profound, is the theory that the pyramid was a repository, not of bodies or treasure, but of knowledge itself. Its silence, its lack of hieroglyphic inscriptions might be intentional, designed to speak to any civilization, in any era, through the universal language of geometry. Mathematical constants like pi and phi are unchanging regardless of culture or time, unlike hieroglyphs, which require deciphering, or papyrus, which crumbles to dust. Geometry endures. By embedding these ratios in the pyramid's dimensions, its builders created a message that could be understood by any advanced civilization capable of measurement. It could be a safeguard against catastrophe, a flood, a climate collapse, a civilizational forgetting that wipes away all written knowledge. By building something massive enough to survive millennia, its creators ensured that future generations would find not a pharaoh's name, but a blueprint of cosmic understanding, a reminder of what was known and lost. This concept of knowledge preservation appears across ancient cultures. Stonehenge in England, built around 2500 BC, encodes astronomical cycles in its stones. The massive trilithons of Baalbek in Lebanon, some weighing over 800 tons, suggest engineering capabilities that defy explanation with primitive tools. The submerged structures at Yonaguni off Japan, possibly 10,000 years old, hint at a culture lost beneath rising seas. These sites, like the Great Pyramid, seem designed to outlast their creators, to speak across millennia not through words but through scale and precision. The Great Pyramid, with its mathematical codes and cosmic alignments, could be the ultimate time capsule, a monument built to preserve truth through the collapse of languages, the fall of empires, the forgetting of entire ages. Whoever built it, whatever they intended, they left no name, only a challenge, to measure, to question, to calculate, to wonder what truths lie encoded in angles and ratios that have outlasted every civilization since. Let that thought settle over you as sleep draws near. The empty chamber is not a failure or a mystery, it is a statement. The Great Pyramid was never about one king, one culture, one moment. It was built for all of us, for the future, for the moment when humanity would be ready to read the message written in stone. Beneath the sand, beneath the tourist paths and camera flashes, lies another Giza, one the public rarely sees. Down there, in the dark underbelly of the plateau, stone gives way to deeper silence. Light fades, and the weight of history presses down like the rock itself. For centuries, explorers believed the Great Pyramid stood alone, a single monument, isolated and complete. But modern technology has begun to reveal something far more complex and mysterious. The pyramid is only the surface. Beneath it lies a hidden network, an ancient labyrinth that challenges everything we thought we understood. It began, as so many revelations do, not with a shovel, but with particles from space. In 2015, a group of scientists from Cairo University and Nagoya University in Japan launched the Scan Pyramids project, an ambitious attempt to peer inside Egypt's monuments using muon tomography. This technique detects subatomic particles called muons that constantly rain down from cosmic rays, passing through rock and registering subtle density differences. It's the same method physicists use to examine volcanoes and nuclear reactors without invasive drilling. For nearly 2 years, detectors placed inside the pyramid's chambers and around its base silently collected data, measuring the passage of particles through millions of tons of stone. When the results were finally processed in 2017, they revealed something no one expected, a massive hidden void above the Grand Gallery. It wasn't a crack or natural cavity. It was a deliberate structure, at least 30 meters long, centered within the pyramid's core. The data was clear and reproducible. This was a chamber, a space deliberately carved and sealed thousands of years ago, untouched since construction. When the findings were published in the journal Nature, the Egyptological world erupted with equal parts excitement and anxiety. Was this a lost burial chamber, a construction gap, or something far older, far stranger? The team carefully called it the Big Void, refusing to speculate. But others were less cautious. Some noted that the chamber's position mirrors the grand gallery below, as if forming a symmetrical design, perhaps an architectural resonance chamber or acoustic space. Others pointed to ancient legends of hidden archives buried within the Great Pyramid, repositories of knowledge from a forgotten epoch. Egypt's Ministry of Antiquities responded with silence, then restriction. Requests for drilling or further exploration were denied. The official explanation cited preservation concerns. The unofficial whispers suggested something else, a desire to preserve the narrative, to avoid questions that might unravel accepted history. Since then, new data have only deepened the mystery. In 2023, an updated Mun scan revealed a narrow corridor, roughly 9 meters long, concealed behind the pyramid's northern face above the original entrance. 3D modelling showed it leads to an enclosed cavity, potentially intersecting with larger voids deeper inside. Endoscopic cameras, inserted through microbore holes, captured images of smooth limestone walls untouched by human hands for millennia. No inscriptions, no tools, no evidence of later entry, just emptiness, pristine and deliberate, waiting in the darkness. Simultaneously, ground-penetrating radar surveys around the pyramid's base detected linear anomalies, patterns inconsistent with natural geology. These weren't random fissures, but structured voids forming grid-like corridors stretching beneath the plateau. Between the pyramid and the Sphinx, researchers mapped irregular low-density zones extending downward more than 40 meters. Some form perfect right angles, others connect to known tomb shafts but continue far beyond their documented limits. Could these be natural fissures, cracks in the bedrock? Possibly, but beneath Giza, natural rarely applies. The precision, the geometry, the deliberate patterns all suggest artificial construction, an infrastructure older than the pharaohs. History hints that these discoveries aren't new. The Greek historian Herodotus, visiting Egypt in the 5th century BC, wrote of underground passages and a subterranean lake beneath the pyramid, where Khufu's body supposedly rested on an island. For centuries, scholars dismissed this as myth, the fanciful storytelling of an ancient tourist. Yet modern surveys have confirmed the presence of large water-filled cavities directly beneath the pyramid's foundation, ancient groundwater sealed in stone for millennia, exactly where Herodotus described. In 1837, Colonel Howard Vyse, the same man who found the painted cartouche, blasted his way into a deep pit below the pyramid's descending corridor. He discovered a rough chamber carved directly into bedrock, now called the subterranean chamber. Chamber carved directly into bedrock, now called the subterranean chamber. It resembles an unfinished tomb, but one with no sarcophagus, no burial signs, no purpose anyone can definitively name. Some engineers now believe it predates the pyramid itself, possibly the remnant of an earlier structure or core excavation that later builders incorporated into their design. French archaeologist Auguste Mariette, exploring Giza in the 1850s, described tunnels he called endless as they are ancient, leading away from the Sphinx toward the Nile. British explorer Howard Vyse's notes mention unexplained air currents near sealed doorways, suggesting interconnected chambers below the surface. These clues persisted through the decades but were largely ignored, overshadowed by the visible grandeur above ground. Modern geology adds another layer to the puzzle. Core samples taken around Giza reveal thick deposits of Nile silt between bedrock layers, evidence that the plateau experienced massive flooding long before the dynastic era. The last time the Nile reached that height was during the Younger Dryas, around 11,000 to 12,000 years ago, when global sea levels rose and climate patterns shifted dramatically. If structures existed beneath the surface then, they could have been buried, preserved under sediment, and later rediscovered by Egypt's early dynasties who built above them, claiming an inheritance they didn't create. This isn't pure speculation. In 1992, seismic studies conducted by geophysicist Thomas DeBecke and archaeologist John Anthony West near the Sphinx revealed cavities beneath its left paw, rectangular, symmetrical, unmistakably artificial. Egyptian officials quickly sealed off further exploration. When reporters pressed for explanations, the response was curt. No further investigation planned. To this day, those voids remain unexamined, their contents unknown, their purpose hidden. So what lies beneath Giza? Storage chambers from some ancient construction project? Ceremonial spaces where priests reenacted afterlife journeys? Or something? So what lies beneath Giza? Storage chambers from some ancient construction project? Ceremonial spaces where priests reenacted afterlife journeys? Or something older? Remnants of a pre-dynastic civilization whose knowledge and infrastructure predated Egypt itself? Some researchers believe the underground passages formed a vast ceremonial complex, a subterranean counterpart to the monuments above. Others, more daringly, suggest they are the fabled Hall of Records, a hidden library described in both ancient Egyptian legends and later mystics like Edgar Cayce. Cayce, speaking in trance states in the early 20th century, described a chamber buried between the Sphinx's paws containing records from Atlantis, preserved against global catastrophe. While mainstream archaeology dismisses this as fantasy, radar imaging has indeed confirmed a large cavity beneath that exact spot, sealed and untouched. Whether or not it holds Atlantean records, something is undeniably there, and perhaps that's the larger truth. Every new scan, every radar survey confirms the same thing. The Giza Plateau is hollow, threaded with passageways and voids that defy our assumptions of simple pyramid-on-bedrock construction. The ancient builders didn't just raise monuments skyward, they built downward, into Earth itself, creating a three-dimensional complex whose full extent remains unknown. If the Great Pyramid is the tip of a buried structure, then its true story lies below. The corridors beneath may be older than the visible stones, dating back to a civilization erased by flood or time. Perhaps the pharaohs of Egypt found these ancient catacombs already in place, and built their monuments above them, claiming a legacy that wasn't originally theirs. Imagine, as you drift towards sleep, that beneath every step on the plateau, tunnels stretch into darkness. Their walls might be carved with symbols we cannot read, their chambers might hold artifacts from a world before history began. They wait, perfectly preserved, like hard drives from an ancient computer system, data storage from a civilization we've forgotten. And maybe, just maybe, somewhere in that darkness lies proof. Proof that the Great Pyramid was not the work of Egyptians alone, but a gift or inheritance from a people far older than we've dared to imagine. A civilization that built not just upward toward the stars, but downward into Earth, creating a network of knowledge meant to survive the end of their world. Dawn breaks over Giza. The first light touches the pyramid's tip, turning the limestone gold against the deep blue of fading night. The city beyond still sleeps, unaware that beneath this calm horizon lies the weight of a forgotten world. For thousands of years, the monument has stood as if waiting for the right tools, the right minds, the right moment to finally speak. By now, we've walked together through the fractures in the official story. We've seen the questionable painted name, the impossible dating, the engineering that defies Bronze Age tools, the precision beyond reason. We've explored the mathematics that encode cosmic constants, the stellar alignments pointing to prehistoric skies, the empty chambers that mock the idea of royal tombs. We've descended into hidden tunnels stretching beneath the sand, and we've confronted the pattern of silence, the deliberate concealment, the denied access, the suppressed evidence. All of these threads weave together into a single tapestry, revealing a truth that challenges not just Egyptology, but our entire understanding of human history. The Great Pyramid may not be what we've been told. It may not belong to Khufu or even to ancient Egypt as we understand it. The evidence, fragmentary, contested, but persistent, points to something far older, far stranger. Ancient myths scattered across the planet remember a great catastrophe that drowned the world and buried memory in mud and ice. Plato wrote of Atlantis destroyed around 11,600 years ago, the same epoch geologists associate with the Younger Dryas, when sudden global melting flooded continents and reset climate patterns. Egyptian priests told Plato that their civilization had only inherited fragments of a far older world, one destroyed by fire and flood. They called its survivors the Shemsu Hor, the followers of Horus, semi-divine beings who ruled before the first dynasties, teaching writing, architecture, and the ordering of the heavens. To the Egyptians, the Great Pyramid and Sphinx were not beginnings. They were reminders, monuments from the first time, Zep Tepi, when gods walked among humans and built in stone what would outlast forgetting itself. If that sounds like legend, the Earth itself seems to agree. Around 12,800 years ago, ice core records show evidence of cosmic impact, platinum spikes, nanodiamonds, widespread burning. Sea levels rose more than 120 meters in a geological instant. Entire coastlines vanished beneath the waves. What would survive such a reset? Not cities of wood and clay, not libraries of papyrus, but perhaps stone, massive, precisely cut, mathematically encoded stone. If a civilization existed before that event, call it Atlantis or leave it nameless, its survivors would have migrated to high ground, to river valleys spared the worst floods, the Nile Delta, the Tigris and Euphrates, the Indus Valley. There they might have preserved what they could, encoding their science in monuments too durable to erase. Astronomy, geometry, mathematics, resonance, all folded into structures that speak not through fragile language, but through eternal proportion. The Great Pyramid, in this view, isn't a tomb or even a temple. It's a message across epochs, a monument built not to glorify kings, but to preserve knowledge through the collapse of worlds. The numbers align with eerie precision. The Orion correlation points to 10,500 BC. The end of the Younger Dryas falls around 9,600 BC. The emergence of Göbekli Tepe with its sudden megalithic sophistication appears at 9,600 BC. The Sphinx's water erosion suggests 7,000 BC or earlier. These aren't isolated anomalies. They're echoes of a forgotten fire, embers of knowledge that survived catastrophe and ignited again in scattered places. Egypt, Mesopotamia, India, Central America, each carrying fragments of the same blueprint. Perhaps the builders of the Great Pyramid were inheritors of that fire, refugees from cataclysm who encoded their world's understanding in indestructible form. The limestone and granite become pages, the angles and ratios become text, the chambers become chapters of a book written in mathematics, the only language that survives the death of civilizations. They knew, perhaps, that it would not be understood immediately. Maybe that was the point. The pyramid wasn't built for its own time. It was built for us, for whoever would rediscover it after the next cycle of destruction, the next great forgetting. A seed of knowledge, waiting to germinate when humanity was ready to read its message. The idea of cycles runs through every ancient culture. The Hindus speak of yugas, repeating ages of rise and fall. The Mayans described 5 suns, each world destroyed and remade. The Egyptians believed in the recurring flood of Nun, the primordial waters that reset creation. Even modern science recognizes Earth's pattern of catastrophes, magnetic reversals, climate shifts, impact events roughly every 12,000 years. If the Great Pyramid dates to the last such turning, its builders may have known what we're only rediscovering, that civilization is not a straight line but a circle. We rise, we fall, we forget, and we begin again. Maybe that's why the pyramid endures, not as proof of one lost civilization, but as the heartbeat of many, a pulse of memory across ages, a reminder that we have been here before. Its silence is deliberate, its perfection is a language we're just learning to read. And what of the voids discovered inside, the tunnels below? Perhaps they hold more than air and stone. Perhaps they contain records waiting to awaken, not in words but in resonance, in frequencies that will one day vibrate again and speak the story of the first time. For now, the monument waits. Each dawn, sunlight climbs its face exactly as it has for millennia, tracing the same lines, igniting the same stone. The earth turns, the stars shift, the ages pass, but the pyramid does not move. It is the needle that stays still while time spins around it. The axis, the anchor, the message. Maybe that's the final secret. The Great Pyramid was built long before the Egyptians, not as a monument to death, but as a mirror for the living. To remind whoever comes next that we have been here before, that we knew these truths once, that we encoded them in stone so they could never be completely lost. As night falls again, its shadow stretches toward the stars it once mirrored, silent, eternal, watching, waiting for us to remember what we've forgotten. Where are you tonight as you listen to these words? What time is it where you are? And when you look up at the night sky, Do you see the same stars that wheeled overhead when the pyramid was new, or older still, when it was already ancient? The Great Pyramid asks us only one thing: to question, to measure, to wonder, to consider that history is longer, stranger, and more mysterious than any textbook dares to teach. Let that thought drift with you now into sleep. The monument stands in the desert, its stones holding secrets in patient silence. It has outlasted empires, languages, entire civilizations. It will outlast us too. But perhaps before it does, we will finally understand what it's been trying to tell us all along: that we are not the first, that we are not alone in the river of time, that knowledge, once gained, can be lost and found again, and that somewhere in the mathematics of stone and the geometry of stars, a message waits, written by hands we've never named, for minds not yet born. Sleep now, dream of pyramids and stars, of civilizations rising from ruins, of wisdom preserved in the one language that never dies. The pyramid will still be there when you wake, patient as stone, eternal as the mathematics it embodies, waiting with the stillness of ages for the moment when we're finally ready to read what it has always been saying.